Hi, everybody. We are going into the second part of chapter five. So, what we've been doing up until this point has been a couple of things, which is we've been looking at different types of calculator problems where we're solving for N, solving for IY, solving for PV or PMT. So, now when we get into the second part of this, we're going to be looking for some other stuff. So, one of the big things that we talk about is compounding periods. So if you remember from the end of the last class, what we did with compounding periods was we took something that was like, say, annual and made it monthly. And when we did that, you remember that the longer the compounding periods, the higher the future value is going to be. So the more compounding periods you have, the higher that future value is going to typically be. So what we're looking at here is that how do we translate that into more of an apples to apples comparison? So when we talk about APR or annual percentage rate, what we're doing is talking about how interest rates are typically quoted. And so for us, that gives us a really good idea of what we may or may not do. So with compounding periods, what we have is something called an effective annual rate or EAR. So, what you're trying to do using this formula is you're taking what the APR is and given the compounding period, and then that will give you your apples to apples comparison, this EAR formula. So, what you're doing essentially is just making this into, oh, okay, well, we can compare and see exactly where we're at with the different compounding periods. So here is a question involving a perpetuity. So the question is, what is the present value of $100,000 per year in perpetuity at 10% interest? So first of all, if you think about like the word perpetual, if you think about what does that mean? Perpetuity means something goes forever. Now, in finance, it's pretty rare that you do see perpetuities, but you do see them. They are out there. And so that's why we're covering them in case you're ever out in practice and all of a sudden you run into it. You're like, hey, what is this? I never heard about this. So that's kind of why we do it, but it is pretty rare. So the thing is, how do you solve this formula? So when we look at a perpetuity, what we're doing is it's a very simple formula. All we have to do is take the 100,000 and divide it by 10%. So again, all you're doing is taking 100,000 and dividing it by 10%. And when you do that, you end up with a really good idea of, okay, this is what this perpetuity should be worth. Now, the difference between a perpetuity and an annuity is an annuity is for a finite period of time. So, in other words, we know when an annuity begins, we know when an annuity ends. And so, if you look at like in this timeline that I'm going over here, with an ordinary annuity, if you look at the very top, you can see that okay, we have a year one payment, a year two payment, a year three payment, and then finally it goes to whatever that N is going to be. But we know that that N is going to end. So with an annuity due, that's a little bit different, and we're going to get to that in just a minute. So present value of an ordinary annuity. So how exactly do we do an ordinary annuity? Well, keep in mind an annuity by definition is an annualized stream of payments. So what we're doing this is we're doing this on the financial calculator, and we are going to see on the financial calculator exactly how to do this. So just like everything else, I put the formula on the screen only because I want you to be able to conceptualize what we're doing rather than just randomly punching numbers in a calculator. And so a lot of times when you see this and you see it conceptualize it, flips on that light switch and you're like, oh, wow, okay, I can get this now. And so that's kind of what we are looking at. So here is an example of an annuity. So what we're doing here is what is the present value of $100,000 per year for 3 years at 10% annualized interest? So I will give everybody just a moment and we will go over this problem. So when you look at this on the TI BAI2 Plus, here is what you're looking at. So keep in mind what we want to do at all times is hit second right here and then clear. And that clears out all our work from the previous problem. So what we're trying to do here is what is the present value of $1,000 per year for 3 years at 10%? So we know in this case, our N is going to be 3. So we hit 3 and then we hit N. And then we know our interest is 10. So we're going to hit 10. And then we're going to hit IY. Present value, we are trying to figure out. So that's the question. What is the present value? Our payment is going to be 100,000. And that is the payment. And that is, again, that's going to be a positive number because that's a cash inflow. Because if you're purchasing an annuity, what you're purchasing is an annualized stream of cash flows. Now, the trick to this is the future value is going to be 0 because at the end of the annuity, that annuity isn't going to be worth anything. So you would put in right here 0 for future value. And then we go compute present value. And I think somehow that switched or that. So we go back, compute present value. And of course, our calculator is messed up here. So we're going to just do what we would do if we were doing this on a test, start over. So we would do 3 is N, 10 is IY, PV is what we're trying to figure out, 100,000 is your payment, 0 is your future value. We go back, compute present value, and there's your answer. It's currently worth 248,685. And so that is exactly how you would know how to do this on the financial calculator. So going back to the slides here, that would be how you would do this. So an annuity due. So I have this as a problem in your homework set that you're going to be working. So I want to make this really clear. There is not going to be at all an annuity due problem on the test. And the reason is you have to go change your calculator settings in order to do this. So if you go on my YouTube channel and you look like how to do an annuity due problem, I have an example on there of how to do it on the financial calculator where you can go in there and do it. But what you have to do is you have to change your calculator setting to beginning mode. Well, the problem is if you do this, what will happen is just like everything else in the calculator, that beginning mode stays in there. And then if you work a problem and you don't switch it to end mode, then your answers are going to be messed up. And we just don't want that. We do not want that on a test that your calculator's messed up and it's in beginning mode and all the rest of the questions are in end mode. So that is the big point why it is not on the exam at all. So what you do in order to change it to annuity due is hit second payment, then second enter. That is what puts it into begin mode. And again, there's a video out there that I show everybody how to do this. Quick reference, you can go in there and see exactly how to do it if need be. So going to an annuity, let's say that we want to find a future value annuity. Now, in the previous problem, what we did was we calculated the present value of an annuity. Now we want to kind of flip the script a little bit and do, hey, what is the future value of an annuity? So how much money will you accumulate by the end of year 4 if you deposit $1,000 each year for the next 4 years into a savings account that earns 3% per year? So you can see on this timeline, it shows us exactly, what it is doing. So what it's saying basically is that you deposit $1,000 each year. Okay. So how much is that $1,000 worth at the end of the 4 years if it's at 3% interest? So I will give everybody just a moment and then we will go do this on the calculator. So what we'll do from the previous problem is hit second and clear. And again, that is clearing out all of our work from the previous problem. So none of that is going to be an issue at all. So what you're doing in this case is 4 is going to be your N. 3 is your IY. Your present value is 0. And what this means is currently the annuity is worth 0. You have 0 saved. So basically what you're doing is depositing $1,000 each year. So 1,000 negative, because again, it's a deposit, it's an outflow, is your payment. And then we go to compute future value, and our answer is 4,836. 4,000, sorry, 4,183.63. 4,183.63. So that is what we are doing there. So if we go back to the future value of annuity, this is what this formula would look like. So now we're going to solve for I. So we got a problem here. In 20 years, you're hoping to save $100,000 towards your kid's college education. You are able to save $2,500 a year for the next 20 years. What rate of return do you have to earn in order to achieve your goal? So I'm going to give everybody just a minute and we will go about trying to solve this. So we'll take a pause for a minute and then we will go to the calculator. All right, so let's go and do this on the calculator. So again, we're going to hit second and clear and just clear everything out of there from the previous problem. So our n in this case is going to be 20. So the thing is that, what you do is you put 20 in for n. Then your IY is what we're trying to figure out because what it's asking in the problem is what is your rate of return you must earn in order to do this. So IY is what we're trying to figure out. So our present value, if you think about it, is it given in the problem at all? And you think, no, it's not given in the problem. So we're assuming that we have 0 saved right now because it's not given to us in the problem. So we're going to have an outflow, 2,500. We're going to put the negative sign right behind it. That's going to be your payment. And what we want to have is 100,000 saved. And that's going to be your future value. And then we will compute the IY. And the answer is 6.77%. 6.77%. So again, going over this on a calculator, your N is going to be 20. Your payment is a negative 2,500. Future value is 100,000. present value is 0, and your I would be 6.77. So here is the next question. All right. So now we've solved for PV, FV, and IY. Now it's the same thing where we're going to be solving for N. So here is what the question is. You're planning to invest 6,000 at the end of each year into an account that pays 5%. How long will it take before this account is worth $50,000? So I'll give everybody a minute. We'll pause here and then we will work it on the calculator in just a minute. Okay, so let's go over this on the calculator. So again, we're gonna go ahead and second, and then we're gonna clear everything out of here. So what you have is, in this case, we're trying to figure out the N. What exactly is the N? So we know that our interest is going to be 5. Excuse me. So 5 is your IY. Present value is going to be worth 0 because, again, we don't have anything saved right now. But 6,000 negative is going to be the payment because, again, that's a cash outflow. 50,000 is your future value. And then we go compute our N. And our N in this case is 7.14. Our N is going to be 7.14. So again, this shows you, if you use the financial calculator, exactly what you are doing. Your IY is 5, PV is 0, payment is negative 6,000, and future value is 50,000. So here is a great McDonald's example of an annuity. So you hit, boardwalk in this McDonald's game. So if you remember this McDonald's game, it was from several years ago. And what it was like pieces of Monopoly. And what you would do is go in there and you would, um, if you got a boardwalk piece, you get $1 million annuity. That basically means it's paid out 50,000 per year for 20 years. So if you were going to say, what is this annuity worth today? How would you do it? And what would be the answer? So again, we'll give everybody just a minute and then we will calculate and discuss. All right, so let's go to the calculator and work this. So again, we're going to clear everything out from the previous problem. So here's the thing. Your future value in this case is going to be zero if we're taking this from right to left. So if we think about this, you're getting $50,000 a year for 20 years. So that is the $1 million. You don't get another $1 million at the end of it. It's not a $2 million annuity. It's a $1 million annuity. So 50,000 is going to be the payment. And again, that's a positive inflow. So we don't make that negative because that is what we are getting every year for 20 years. So then our IY is 10 and then 20 is the N. And then we go compute what the present value is. And it's 425,678. What that means is you would be indifferent between taking 425,678 today or taking the $50,000 a year for 20 years. You would be indifferent between the two. So anyways, what I also wanted to tell everybody was on my YouTube channel, there's also a video that explains this problem a little more in depth that you may want to look at. So this is the final thing, okay? And this is just a little exercise in a problem set. So what we're doing with this is these questions are going to be on your quiz this week. And so these are going to be some of the questions. These are short versions of previous test questions. So we're not going over them now, but we will go over them after the quiz ends. So if anybody has any questions or needs anything, please let me know. And look forward to seeing everybody again next week.